So I'm going to teach you another system solving method today called elimination. What was the one I taught you last day? Substitution. And what is the whole idea behind substitution?
That you can take one thing and put it into another
Yeah.
and get both equations.
You take one thing and substitute it in for another thing, and that eventually gave you your answer. And that was based on the meaning of the word substitution. And so, therefore, elimination would hopefully be based on the meaning of the word elimination. Right? So, let's just think about that. Okay? Well, I'll fill in this blank first. Elimination is what we're learning today. Okay? So, just in your own words, try not to think too much in a mathematical sense, but in any other sense that you know this word. What does elimination mean? What does it mean to eliminate something?
Take it out.
To take it out,
Get rid of it.
to get rid of it,
Remove it.
to remove it,
Delete it.
destroy it, obliterate,
Conquer.
not necessarily discriminate, but that can also cause things to disappear. Pardon me? Exterminate. Okay, sorry, I misheard you. Right? To eliminate something means to make it disappear. Can we say that generalization? Okay? Whatever the context, right? If you get eliminated, that means you die. If you eliminate the money from your bank account, that means it disappears.
Oh, sadly.
Right? If you eliminate a target, it is no longer there. You get the idea? Okay? So to eliminate means to make something disappear.
Like magic.
Or vanish, I guess we could say as well. Okay? That definition will help us to understand how to use the method of elimination to solve systems. Okay? Because you're essentially doing that. Really what you do in elimination is you add or subtract your equations together with the intention of eliminating one of your variables.
Oh my goodness.
And then solving for the other. And I'll show you how to do that. Some people think that this is an easier method than substitution. I can't say one is easier than the other. Personally, I like substitution better. I will say that substitution is more universal. But there are circumstances definitely where elimination is nicer to use. And I'll hopefully give you an idea of where those situations will occur. So let's just look at a really simple example of how to use elimination. Okay? So I've got two lines, both in general form right now. X plus 2y equals 13, x minus y equals 8. Okay? Fairly simple system. We could solve it using substitution. Right? We would just have to solve for one of the variables and go from there. But here's how you do it with elimination. What you do is you take your two equations. So x plus 2y equals 13. And you stack them on top of each other. Okay? Making sure that your x terms line up, your y terms line up, and your constants line up. That has to be for sure before you try to do any kind of elimination. Okay, so stack your two equations, one on top of the other, and make sure your x terms, your y terms, and your constants all line up. You could also stack it the other way. You could take this bottom equation here and put it on top there. It doesn't matter. Just put one on top of the other. Okay? What we're going to do next is we're going to add or subtract these two equations with the intention of eliminating one of the variables. In this case, I'm going to eliminate x. Okay? Here's how that works. If I subtract the bottom equation from the top equation, notice what happens. Okay, I just subtract the corresponding terms. So the first thing I would do is I would go x minus x, this is a minus here, x minus x, that gives 0, okay, or 0x, but basically 0. So x got eliminated. Let's see what's left. Next I go 2y minus negative y. 3y. That's the same thing as 2y plus y, right? So that's plus 3y. And then the equals. And now I go 13 minus 8, giving me 5. Okay, so I just want to pause here and note that we have created a new equation by subtracting the 2 that we started with. And most importantly, that subtraction eliminated one of the variables. Notice that if there was still an x term here, you can't solve for anything. Right? To solve an algebraic equation, at least at this level, you need to have only one variable, and then the rest of the terms are numbers. If you don't have that, you can't solve it. Okay? So, because we've successfully eliminated x, we can now solve for y. Alright? So, this is y equals... 3y equals 5, and then divide both sides by 3. Y is 5/3. So we have y. Now to find x, right? And you find x the same way you've been finding it all along. You can choose any equation. You can choose this one, or you can choose this one. Put in the known y value, and solve for x. So I'm going to use, I'll use this guy.
So you still have to do substitution then?
A little bit, yeah. So x minus, and the value of y here is 5/3 equals 8. Okay, so there's nothing in front of those brackets, so I can just take them out. And I'm going to bring over the negative 5/3. That becomes positive. Right, change sides, change signs. What's the rule when I add fractions? Nope, common denominators, right? So I put the 8/1 and then multiply top and bottom by 3, giving me 24/3 plus 5/3, and then you add the tops, 29/3.
Can you reduce that?
Can't reduce it, you're right. So the intersection point is 29/3, 5/3. A little bit of fraction fun. Good?
Yeah.
So again, the main idea behind elimination is to either add or subtract your equations so that one variable gets eliminated.